Hello everyone, I am Disha K of CSE Cybersecurity Department from Sri Venkateshwar College of Engineering, Bangalore. Today I am going to discuss about the vector calculus. Introduction to the vector calculus. Vector calculus is a branch of the mathematics that deals with the vector field and the differentiation and the integration of the vector function. It provides a powerful tools for the analyzing and solving the problems in physics, engineering and other fields. Vector calculus is an extension of the ordinary calculus to the function of the multiple variables. Vector field. A vector field assigns a vector to each point in a given region of the space. It represented by a function that takes a point in a space as an input and a return a vector as an output. Vector field can represent the physical quantities such as a velocity, force and electric field. Vector field are often used in a model. For example, the speed and direction of the moving fluid throughout the three-dimensional space, such as a wind and other strength, and the direction of some forces such as a magnetic gravitational force as it changes from one point to another point. Gradient. The gradient of the scalar field is a vector that the point in the direction of the steepest increase of the field. It is defined as a vector of the partial derivatives of the field with respect to its variable. The magnitude of the gradient represents the rate of change of the field. The gradient in the mathematics, the differentiation operation applied to the three-dimensional vector value. Those the three components are the partial derivatives of the function with respect to the three variants. Divergence. The divergence measures the degree to which a vector field flows outward or inward from the given point. It is calculated using the dot product of the vector field with a del operator. Divergence can be used to study the behavior of the fluid flow, electric field and other phenomena. Next is title. The curl measures the rotation or circulation of the vector field around a given point. It is calculated using the cross product of the vector field with a del operator. Curl is used for the understanding the fluid dynamics, electromagnetism and other phenomena involving rotational motion. Line integrals. A line integrals involves the integrating a vector field along a curve in a space. It represents the total field of the vector field along the curve. Line integral can be used to calculate the work done and other quantities. A line integral in a vector calculus can be measured a total field given by a field along the curve. For example, the line integral over a scalar field. Green's theorem. It states that the line integral around the boundary of the plane region that related to line integral around the closed curve to a double integral over region enclosed by a curve. It established a connection between a line integrals and surface integrals. Green's theorem is a fundamental tool in a vector calculus and has application in the fluid dynamics and electromagnetism and more. Surface integrals. In a vector calculus, the surface integral is a generalization of a multiple integrals to the integration over a surface. Sometimes the surface integrals can be through the double integral. A surface integral involves the integrating a vector field over a surface in a space. It represents the total effect of the vector field on the surface. The surface integrals can be used to calculate the mass flow rate and other quantities. Gauss theorem, it also called the divergence theorem. Gauss theorem related a surface integrals of the vector field to the volume integral over a region enclosed by a surface. It established a connection between a surface integrals and volume integral. Gauss theorem is a powerful tool in a vector calculus and its applications in electromagnetism, fluid dynamics and other fields. Stokes' theorem. It states that the surface integral of the curl of a function over a surface bounded by a closed surface is equal to the line integral of a particular vector function around that surface. Stokes' theorem related a line integral of a vector field around a closed curve to the surface integral over a surface bounded by a curve. It established a connection between the line integral and surface integral. Stokes' theorem is widely used in physics and engineering, particularly in a study of electromagnetism and fluid dynamics. Applications of a vector calculus. Vector calculus play a crucial role in physics, especially in the field of electromagnetism, fluid dynamics, and quantum mechanism. It is used in engineering for the analyzing and designing systems involving the force, motion, and field. Vector calculus also find the application in a computer graphics, robotics, and a weather. It is a study of a partial derivative of the equations. Conclusion of the vector calculus. Vector calculus provides an essential tool for understanding and solving the problems involving the vector field. It encompasses the concepts such as the gradient, divergence, curl, line integrals and surface integrals, and the theorems like the Green's theorem and Stokes theorem. Through its application in a various field, vector calculus helps us a model and analyze the phenomena in a physical world.